Hello everyone. In today's lecture, we are going to see about ARM Cortex-M0 architecture. So, this is first let us see why do we want to learn about ARM Cortex. Where ARM Cortex is being used? What is the what are the applications or what are the domains where ARM Cortex is being used? If you see this diagram, see whether it is an ATPA partner or an RTAS partner or a software partner or a tool partner, right? All these persons use ARM. All these companies use ARM. So when you see this diagram, almost all the big giants are using ARM. Why so ARM is very important. And one another thing is Intel has replaced it was being replaced with ARM by Apple. Why? So what made ARM so important? So let us see what is ARM Cortex. An ARM Cortex processor comes in different variants, each designed to cater to specific requirements in terms of performance, efficiency, and applications. So one reason why ARM was being so ARM Cortex or ARM in general, all the variants are very popular because ARM gives licensing for the base. That is, ARM provides, it doesn't provide only the processor, it provides the licensing for the base fundamental fabrication, and it gives room to expand for every customer according to their needs. So this is the reason why ARM was being used. And power efficiency is one another factor. So because of all these things, because of all the its performance is very good, that is the reason why even Apple was being using ARM and ARM Cortex variants. The different ARM Cortex variants are Cortex A, R, and M. It depends on the applications for which it is being used. Suppose if it is for smartphones, tablets, or the computing devices, then ARM Cortex A series was being used. Suppose if it is for automotive systems, industrial control, and hard disk controllers, ARM Cortex R series is being used. Coming to IoT applications and applications which require low power consumption, then ARM Cortex M series is being used. So in these series, different n number of variants are also available. So we are going to discuss about one of the processor in this ARM Cortex family, that is ARM Cortex-M0, which is the smallest of ARM processor, that is a base processor. The Cortex-M0 has small silicon layer and it consumes less power. Then the code footprint is also very less, very minimal, and 32-bit performance was achieved with the help of an 8-bit processor. Then ultra low gate count of the processor enables its deployment in analog and mixed signal devices too. These peculiar features has made ARM Cortex M0 a prominent or it plays a vital role when we speak about ARM series. These are the different applications where ARM has been used. And now if you see the ARM Cortex-M, based on different parameters, here in the y-axis size is there, FPG in the x-axis, FPGA low cost, high performance microcontroller unit. When you see the performance of ARM Cortex-M4 is very high when compared to ARM Cortex-M0. And also the size, if you see for ARM Cortex M4, the size is more when compared to Cortex M0. And if we see the basic features of ARM Cortex M0, it has von Neumann architecture. Already we have discussed about von Neumann architecture and Harvard architecture in the previous lectures. So it uses a 32-bit architecture. It uses thumb technology. Then the most important one is ARM Cortex-M0 has NVIC controller, that is nested vector interrupt controllers. It can use around 32 nested interrupts. It can handle an AHB light master interface bus is there. Then ultra low power support is there. Then core site compliant debug has been as an additional feature. It is RTL configurable. Then gate count varies from 12 to 25,000. ARM Cortex-M0 is programmed in C, and we do not need to write any assembly code. Then it can follow thumb instruction set also. Thumb technology, it supports thumb technology too. Then it is forward compatible with other M series processors. It is binary compatible too. Then multiple memory access or interrupts between the transfers is also possible. This is the architecture of ARM Cortex-M0. If you see here, this is the part which handles nested vector interrupt controllers. So if you see, it can ARM Cortex-M0 can handle up to 32 interrupts. So once when one interrupt enters inside and it is being processed, the second interrupt can enter inside. Similarly, this is what is known as the nested interrupts, nested vectored interrupts. So this is a major, if you see here, this is the major feature of ARM Cortex M0 processor. And here interrupts comes inside, and we have another wake up interrupt controller in the case of ARM Cortex M0. This is a processor which is going to process. So this is a main feature. Then we have the bus matrix which has been connected to different address buses, data buses, and so on. Then we have the optional debug unit also, which is an additional feature, and this includes the breakpoint and watch point units along with the debugger unit. Then we have the debug access port, which is being connected to the JTAG debug port. JTAG is Joint Test Action Group. It's another kind of communication port. So through that it has been connected, and for through the bus matrix, the HB light interface connects it to the other parts of the system. So these are the features already which we have discussed. And how interrupts is being processed. As like the other processors, ARM Cortex M0 also handle interrupts the same way. That is, these are the set of instructions which have been given for execution. This is a main program. So after instruction 4, it comes across an interrupt. So once if it sees an interrupts, then immediately the next address to be executed will be pushed into the stack, and then it takes the interrupt vector routine. It takes the interrupt vector routine, or it takes the interrupt subroutine, or it could be a procedure, anything, right, based on what kind of interrupt it is. So after execution of this interrupt, once after seeing the return instructions, or the instruction which directs the processor to come back to its original main program, it will come back by popping out the instructions from the address of the instruction from the stack. This is not only for ARM Cortex M0, this is applicable for all the processors in general. This is the way how. Here especially we are discussing because it has NVIC concept, that is next nested vector interrupt controller is a special feature of ARM. So this is a expanded diagram of NVIC. So what is the advantage of NVIC is the main advantage, it speeds, it reduces the latency, right? So see here we have n number of peripherals and IO ports. So all these signals, whatever is entering inside, will be considered as an interrupt, right? So it can be a normal interrupt or it can be a non-maskable interrupt, right? Whatever the interrupt is, the NVIC controller will handle it. Then it will even system exceptions will be inputs for NVIC, right? Then it will give it to the processor for further processing. So NVIC is the main feature of ARM Cortex M series. And this is the timing diagram which shows the NVIC. That is, see, here we have considered two interrupts. One interrupt is being processed at this point. At this point, one interrupt is being processed. See, the first interrupt gets completed only at this point. Immediately when it sees an interrupt, the and next address to be executed is pushed to the stack. Then it takes the interrupt service routine and it proceeds with the interrupt service routine. Right? See, here first interrupt was being completed only at this point. But before completion of this interrupt, see, second interrupt was being accepted and second interrupt was being processed, right? So it do not wait for the first interrupt to get completed. This is what is nested vector. So inside one interrupt, another interrupt is there. If any third interrupt request comes, then again the third interrupt will start at this point a while after the second interrupt. So this is what is the concept of NVIC, and this helps to reduce the latency, thereby improves the performance. And a wake up interrupt controller is a peripheral that can detect interrupt and wake the processor from deep sleep mode. Then it is not programmable and does not have any registers or user interface. It operates entirely based on the hardware signal. Then we had breakpoints and watch points in the debug units. These are features of debuggers that allows us to pass the execution of the code at specific locations or conditions to check or to debug. Breakpoints are set of lines or codes, and watch points are set of variables or expressions. Then debug access port is a module that contains a set of registers and logic required to provide microcontroller debugging via debug interface. And it has two main components, debug port and access port. This is connected to the external through a JTAG. This is a main system bus, AHP light interface, that is advanced high performance bus. This is a version of AHP system bus aims at single master system designs. So one will be acting as a master and the other all will be slaves. So ARM core is the only master permitted. The system bus allows the processor to access resources on the base board and on the other modules. So I hope it's clear. So if we discuss about the architecture, the NVIC is a major thing, major part of feature of ARM Cortex M series. Thank you.